Hi. So let's discuss about the queues. So we will discuss what is the queue, how the queue works, and what are the important operations. And third, we will implement the queue using a list in Python. So let's see what is the queue. So imagine you are at supermarket or any shop and there is a long line of people. So people enter that queue and whoever is at the front of the queue will get served first. So if you are at the first, you will first to have your checkout and then you can go out from that queue. So that is as simple as that. And so whoever is or whichever element is getting first in that queue will be first to get out. So that is why it is called as the first in first out. So as you can see here, people or element are uh, getting into the queue from the rear, and whichever element is at the front of that queue is getting first to get served or first to get removed. Okay, so let's look at the important operations for the queue and we'll see how it works. So first is called as enqueue. So what is enqueue? So it is simply the act of putting the data in the queue at the rear end. So that is called as enqueue. So we have enqueue 2 here, then we can enqueue 3, then we can enqueue 4, then we can enqueue 1. So that is called as enqueue operation. Next is dequeue. So whichever element is there in the front, we'll remove that element and we'll return its data. So here it is 2. So we'll remove that element and we will return its data that is 2. So that is called as dequeue operation. So again, you can see here all the elements are moved to the respective index. So 3 will come at front once we remove 2. So this is implemented as so we are going to implement it as list in Python. And list is nothing but dynamic array. So all the elements are getting moved just due to that uh, dequeue operation, and that's why it is kind of expensive operation you can call. Uh, the complexity is O of n, because again in the memory uh, all the elements has to be moved. So let's discuss about the next operation, which is peak. So in this operation, we will just check which element is at the front. So here you can see the 3 is at the front after we remove the 2. So we'll just return the 3, we will not remove. So that is called as the peak. And the last operation is size. So we'll just check the size of the cube. What is the size? How many elements are there? So as you can see, there are 3 elements in the cube. So and that is called as size. So let's see how we can implement this in Python using the list. This to here. So yeah. So to implement the queue using the list, first we will just create a class. called as queue. Then we will define a constructor. So the first argument is always self. Then in that constructor, we'll do self dot queue is equal to a list. So we are just instantiating an empty list here. You can also do like this one. Then first operation is enqueue. So we'll define that. So here what we will do is we'll use the append operation of the list. So self dot queue dot append. But we need the data to append. So we will take the data as argument and we will pass it here. So how we can use the append? As you can see, self.queue is a list. So we can use all the methods that are available for list. So append is one of the method which will add the data at the rear. So if you consider this queue, and if I now enqueue, which will append the data, which will append the to here. So it will go at index 3. So this is 0, 1, 2, and 3. So that is the append operation. Then we will define the decay. Self. The data is not required because what we are doing in dequeue is just removing the front element, which is at index 0, and we are returning it. So there is already operation for it, which is called as pop. Return so self dot q dot pop, and we will remove the 0th element. If you use the pop without the index, what it will do is it will remove this element which is at the last. So it will essentially create a stack instead of queue. So this is very important to remember. I also covered stack in another video. You can refer that to implement stack. So this is the queue. But what will happen if this list is empty? It will return an error. So to mitigate that, we have to first check if the list is or the queue is empty. So we will define a method called as is empty. So we will return full self dot queue. So let's understand this. So this bool or boolean method on the self dot queue, which is essentially a list, will return the boolean state of the list. So if the list is empty list, it will return false, and if the list has some data, it will return a true. But here we want the inverse logic. So whenever a list is empty, this should return true. So that's why we are doing a not here. Okay. So whenever the list is truly empty, it will return a true. So this will return actually uh, false. So we will inverse that and we will return true. So here if self dot is empty, will return queue is empty. Okay. Then there is the next operation, which is pick. So we'll just return whatever is at the 0th index, that is at the front. So here, so return self dot q of 0. remember, it will not pop or remove that element. It will just return it. And there is nothing in that queue, so we have to return an error. So here we are returning a string, but you can, and that is the correct method, that to raise an error. This is not a correct way, but just to keep it simple, we are returning a string. We can also return or raise an error, not return, raise an error. So that is the peak. Then there is the size. So uh, so return, we'll call the lane method self dot q, and it will return the size. So if it is empty, it will return 0. So that's the implementation of the class. So let's instantiate it to test. So let's create a new queue. Then uh, we can print the queue, but this will not print the actual queue. So if we run this, it will just say main queue object at the memory address. So it will not actually print the queue. So to mitigate this one, what we will do is we will just define another method which is called str. It is called as dunder method or magic method as well. You can search about it. So here we return str for self dot q. Now if we run this one, it will return empty because we haven't enqueued anything. So just we'll do the enqueue. So q dot enqueue. First we will add 4. Let's add 3, then add 4, then add 1. Mhm. So we have added or enqueued the elements. Now let's dequeue, or just first just uh, get that whole queue. So I'm using the F string here. Whole queue. Then we will also print the size. Size that will be q dot size. We have to call it as it is a method. Okay. Then just dequeue. So dequeue, and you have to do actual dequeue here. So q dot dequeue. So it will dequeue the front element and it will return it. So it will print it. Then again, we will print the whole queue of size. Yeah, one operation is remaining, that is peak. So we will peak. So we will return whatever the element has is present on the front. So q dot peak. So the whole queue size peak. Then again we will dequeue another element, and then again we'll print the same things. So let's run this and see what is the error. So the queue is not available. Yeah, that is because we have used the wrong curly braces. So let's run this. So the whole queue we can see 3, 4, 1, 2. Then size is 4, because there are 4 elements. If you pick the first element is 3, then we dequeue. The dequeue, we forgot the space, but yeah, you can see 3, we have dequeue. Then the whole queue is again 4, 2, 1, the remaining size is 3. If you pick front element is 4, then we again dequeue. So we dequeued 4 in the whole queue is 1, 2. The size is 2. And if you pick, the peak is 1. So that is how you can implement the queue using the list. It is not very efficient, as we saw that a list is essentially a dynamic array, and whenever we are uh, popping this element, Python internally have to move all the elements in the memory. So that is a burden. So this is not an efficient way, but it is just for understanding. There is an efficient structure in Python. It's called as a deck, which can be imported using the collections.deck. And we can also, it is double-ended queue, it is called. So it can be used efficiently to implement production grade code. And if you want to see that, just let me know in the comments. We can implement it in the future videos. So collection.deck is essentially a doubly linked list. So we are also going to learn the linked list in the future videos, and we will implement the stacks and queue in the doubly linked list. So you might ask where this queue is actually used. So whenever you are sending some pages to that to your printer to print, the printer prints it in a sequence. So there the queue is at play. The So similar things like a message queue in a environment. So their messages are sent, they are queue, and then they are processed by the services. So their queues are used. So they are essentially everywhere. In the OS also, to run some jobs, they are queued. So that is where the queue is used, and it is essential to understand. So thank you so much. That's it for today.